entitled Adding, Subtracting, and Multiplying Radicals. So section 7.4 starts out really nicely here. They give us some examples such as, let's take a few here, 4 times the square root of 11 plus 8 times the square root of 11. Now, if you have like radicals, you can combine them together, and this is called adding radicals, just by adding the numbers in front together and saying that would be 12 times the square root of 11. So those are the coefficients. If you remember, we call them variables. These would be the radical coefficients. And the reason you can add radicals is if you remember your distributive property, you can factor out of those two terms the square root of 11, and what would be left is 4 plus 8, and that's how you do it. That's how you add radicals. All right, you can also subtract them the same way. Let's take the cube root. Let's take the cube root of 5a minus 8 times the cube root of 5a. Now, if you add the numbers in front, or in this case, subtract the numbers in front, but Young, I know what y'all are saying, there's no number in front of that first cube root. Well, there is. If they don't have one, remember, it's there, put one. You would end up with a negative 7 times the cube root of 5a. Now, I know what some of you are probably thinking after this, these first few examples. Young, what is the catch? And you know they always got to take something easy and try to make it more difficult. So we are going to go ahead and we'll try to make it a little more difficult here. I'm going to take a few here and we'll work them out. How about, what if they don't give you the same radicals? The square root of, let's say, 27 minus the square root of 75. Well, I always told my lecture students to always pick on the small radical first, the easiest of the two to simplify, and I think most of us would say, well, that square root of 27 looks kind of nice. We've already seen this one tonight. That would be the square root of 9 times the square root of 3, and it would simplify into simplified radical form as 3 times the square root of 3. Now, how about 75? Now, you know what I told my lecture courses this week is if this one's got a square root of 3 in it, I'm leaning toward this one having a square root of 3 in it as well. See, so it's kind of a way to cheat. It's not really cheating if you're smart, but if you take one radical and you simplify it, and it's the easier of the, many you might get, the other one may come out the same as well. So 3 would go into 75 using the product rule 25 times. So you would get 25 times 3, and then the second radical would simplify into 5 times the square root of 3, and oop, there it is. Now you can put them together as negative 2 times the square root of 3. So the trick in section 7.4 is if they don't simplify, we're going to make them simplify by getting like roots. All right, now let's take a few more here and do it. And I'm going to stay with square roots here because those are kind of nice right now. The square root of 9b cubed minus the square root of 25b cubed plus the square root of 49b cubed. Sorry, that's a cube there. Come on, Young, focus. All right, now let me just ask you folks here that's watching this, which of the 3 radicals looks the easiest for you to simplify? I would say number 1, because remember, if you want to simplify this one, the square root of 9, we already know what that is. The square root of b to the 3rd, we can break apart into the square root of b squared times the square root of b. So the first radical would simplify, square root of 9 is 3, square root of b squared is b, so we're getting all of those square numbers out of there to simplify square roots, times the square root of b. Now, what is that cheater's trick, Young? Well, geez, Young, if this one's got the square root of b in it, I'm thinking all of these are going to have a square root of b in it. Now, again, it's not cheating if you're smart. Look for that. Okay, now let's see if we were to take this radical up here and break it apart. The square root of b times what is the square root of 25b cubed would be the square root of 25b squared. Or should I say a friendly square root of 25b squared. The second one over here, the square root of 49 would be what times the square root of b would give me the square root of 49b cubed? It would be the square root of 49b squared. So what comes out of the radical here would be 5b, and there's that square root of b as promised, plus the square root of 49b squared is 7b times the square root of b. So now you can see the common theme here. You can add and subtract all of these like things here. Don't lose that sign in the middle too. And we will get 3b minus 5b plus 7b, I believe, would be 5b, combining those like roots, times the square root of b. Okay, what's that? Fractions, you ask? Fractions? Why, certainly. People are, oh, please, no, not fractions. All right. We'll do them anyway. The fourth root of 48 over 5x minus 2 times the fourth root of 3 over 10x. Now, I have just given you a gift from heaven right here because this second radical is already what? Simplified. You can do nothing with the fourth root of 3. It's already all done. There's nothing you can break that apart into that's going to make it any better than it is. So right away, I'm thinking, I'm going to get this first radical is going to say it's going to be the fourth root of something times the fourth root of 3. Now, 3 goes into 48 using the product rule or your calculator 16 times. So notice we get a friendly fourth root of 16, which becomes, this first fraction becomes 2 times the fourth root of 3 over 5x minus 2 times the fourth root of 3 over 10x. Now notice here, we've got to what? We've got to, if we're adding and subtracting fractions, this goes back to chapter 6. So we're starting to spread exam review on as we kind of come down the stretch here. We need a common denominator, which I think everybody will hopefully see at this point in the game is 10x. So now we're just going to go ahead and make equal fractions here. So we're going to have to multiply the first fraction, both numerator and denominator, by the number 2, which will give us 4 times the fourth root of 3 over 10x, minus 2 times the fourth root of 3 over 10x. See, so we get those like radicals, and I hope my wife gets that phone. And we get 2 times the fourth root of 3 over 10x. But that is not the answer. Oh, that dirty offer of this problem. Why is that not the answer? Well, because I see 2/10 here. Oh, look, they're trying to sneak us a fraction with numbers on the outside that reduces. Would reduce to what fraction? 1/5. So we would end up with this answer. The fourth root of 3 over 5x. Now, if you wanted to put the 1 in the top in front of that fourth root of 3, you could. I mean, they won't in the book because it's understood. But you have to realize there that 2/10 would reduce to 1/5. So you can add and subtract fractions. If you can simplify radicals, I mean, you can do just about everything here in chapter 7 that needs done. All right, finishing 7.4. Now, 7.4 wasn't just about all adding and subtracting and stuff. It also says multiplying radicals. So we're going to go ahead and we're going to look at that here real quick. Now, let's take one that I think you're going to remember from the past here. And I'm trying to pick some different examples that I did with my lecture courses so I don't bore them doing the same ones. Although they might be saying at this point, Young, it's too late, I'm bored. So I'm going to take 2 times the square root of 7 plus 3 times the square root of 5, and I am going to multiply that by the square root of 7 minus 2 times the square root of 5. And my lecture classes were pretty quick on this. When multiplying, they looked at this one and they said, FOIL, Young, FOIL, FOIL. And yes, I said, great job, folks, because you can FOIL radicals, and you can FOIL any binomial. So this is really just considered a few binomials in terms of radicals. So let's look at this. So the first 2 terms, 2 times the square root of 7 times the square root of 7, will give us 2 times the square root of 49 using the product rule. Now I know what y'all are saying, but Young, the square root of 7 times the square root of 7 is going to come out 7. Yes, it is, but I'm just doing this for an example. Hang on. The outside 2 terms, 2 times the square root of 7 times negative 2 times the square root of 5 would be negative 4 times the square root of 35. See, so what I'm trying to point out here is you multiply numbers with numbers and roots with roots. The inside 2 terms, 3 times the square root of 5 times the square root of 7 would be a positive 3 times the square root of 35. And then the last 2 terms, 3 times the square root of 5 times negative 2 times the square root of 5 would be minus 6 times the square root of 25. Now, of course, you have more work to do here. We're not done when you multiply these fun roots together, all right? Because now we have to simplify. So the first 2 terms, this would be the square root of 49 is 7. We'd get 2 times that is 14. And then the square root of 35 does not simplify, so we can't do anything with it. Now the square root of 25 here does simplify because it's the 5. That's one of our friendlies, and we get minus 6 times 5 is 30. Now, we can collect like terms, so I'm going to underline the like terms here. We can combine these numbers. I'll put them in blue here. And we can combine these like roots together. I'll put those in violet. So 14 minus 30 in blue would give us negative 16. And then these 2 put together, since they're like radicals, minus 4 plus 3 would be minus 1 times the square root of 35. So that is all she wrote for that one. Now, are y'all mad I didn't put the minus 1 in front of the square root of 35? I mean, you could put it there. Will the book? Will the software? No. All right, last one, and I'm going to let y'all go and start pounding on these radicals, and I might even do another Wimba chat here with some more instruction later on for y'all. Now let's take one that won't FOIL here. I know what y'all are thinking. Wait a minute, Young. What do you mean one that won't FOIL? How about one like this? The cube root of x plus 1 times the cube root of x squared minus the cube root of x plus 1. Now this is not a FOIL problem because we have a binomial multiplied together by a trinomial. So how do we do those? Well, we just take the first term, and I'll underline it in pretty pine green here. We take this term and distribute it through the second parenthesis. So we're taking that cube root of x, and we're going to multiply it through here. And then in lighter green, I'm going to take this plus 1, and we're going to distribute it through that parentheses, that second parenthesis. So remember our rules from chapter 5. When multiplying a binomial times a trinomial, you just take each of these two terms here and run them through the second parentheses. So let's see what we have when we do this. So if we take the cube root of x times the cube root of x squared using the product rule, we're going to put those together into the cube root of x to the third. The cube root of x times the cube root of x times x would be minus the cube root of x squared. And then, of course, 1 times anything is itself, so we will get plus the cube root of x. Now, the second ones we distribute through. 1 times anything here is just going to keep that second parentheses the same, so we'll just multiply 1 through, but I like 1. It doesn't change anything. So that would just be what's in the second parentheses. Now let's see if we can simplify and do some other stuff here. The cube root of x cubed out front here, well, that comes out as x, the old e over r rule. Now notice what happens to the cube root of x squares. You have a minus, you have a plus, those go out. In addition, you have the cube root of x minus the cube root of x, those go out. So the only thing you have left is this x that's simplified here plus 1 that's way down here on the end, and that would be the final answer. Okay, so I'm going to go ahead and leave it at that. That'll get you at least through 7.4, and I think in my lecture classes we're a little bit ahead of that right now. We finished with 7.5 today, and this week we will continue to go through Chapter 7 and probably finish the majority of Chapter 7 before the end of the week, and that will only leave us with 2 sections in 8, and we will be done. Wow, the light at the end of the tunnel, we're almost there. So this is Bob Young signing off, wishing everyone a great evening, and keep positive, work strong, finish strong. Let's make some A's down the stretch. Good night.